Okay, so this is the beginning of the second meeting for this book club. We're going to be talking about basic data structures. Let me share my screen quickly. Okay, so I've tried my best to prepare a quarter presentation. It's my first quarter presentation, so bear with me a little bit. I would have liked to, or maybe someone else with more pharma experience to present this, but I'm going to try.
It's just me or everyone able to hear?
No, I don't think so. I think yeah.
Oh, you're good. Okay, maybe it's my. Sorry about that.
Can you hear me correctly?
Yes, now we can.
Okay, perfect.
Yeah, for a minute, I was not able to hear you, so just wondering if was it me or somebody else.
Okay. Then I'll continue. If at some point, please interrupt me if you don't hear me or if you don't see me or something like that. Okay. Okay, so let's go. I'm going to present what basic data structures are. We already did a first session on ADSL and how to derive it from SDTM. And we're going to give more of a global, because BDS is a lot of different data sets, but it's like a global data structure that takes into it a lot of others. So let's begin. Okay, so yeah, BDS stands for Basic Data Structure, and it's a very flexible data format that is used for many subject level analysis data sets. There's only one record per subject, parameter, and time point. It's different from ADSL because in ADSL it's only one per subject, but in this case you may have several rows that are on the same subject but taking at different points of time, for example, or taking a different parameter. It has several standardized variables, the same as ADSL, and it's derived from SDTM and ADSL. Okay, there are many subtypes. I have done a small list of what subtypes are there. You can do it in a different way, but this is more or less how I best understood it. So we have like the findings subtype, which is used for repeated measures, like for example taking the blood pressure several times during the study or stuff like that. Some examples of these are the ADBS, ADLV, and ADPC. More on those later. Then we have the exposure type of BDS. They describe what treatment is the subject actually receiving or has actually received, and how much, how often, for how long, etc. We also have time to event data sets that they track how long it takes for something important to happen. Like if the patient has died, how much time from beginning of treatment until the death, and stuff like that. We also have response type of data sets. They record like the subject's response to treatment, like usually with categories similar to improved or worsened or something like that. We also have pharmacokinetic parameters, and these show how the drug behaves inside of the body, like how the drug is absorbed, how much concentration, the rate of elimination, and stuff like this. All of the BDS share the same core structure, but each are adapted for the purpose and have slightly different variables inside of them. So I'm going to go through each of these common data sets. Yes, I'm just going to go to through the same ones that are present in the pharmaexamples website, because as we're going to skip them because they are very, very long examples, and at some point we would like to go to the more fun stuff, like going through tables and listings, or even creating shiny applications with TL and stuff like that. We're going to try to be as thorough as possible, but go as fast as possible as well, to this part of the examples. So some of these common data sets are ADPC, which stands for pharmacokinetics concentrations. It's derived from the SDTM pharmacokinetic concentrations domain, and it measures drug levels in biofluids, for example, in plasma or blood or whatever. It's used in non-compartmental pharmacokinetic analysis. Then we have the pharmacokinetic parameters that is based on the results of the pharmacokinetic concentrations. And here we get some derived variables like the area under the curve, like the maximum concentration. Once we get the maximum concentration, how much time has elapsed to reach that maximum concentration. And it's used for dose response modeling. Then we have the response data, which is derived from several different SDTM domains, like the disease response, the tumor identifications, and the tumor results. This one is often used for oncology studies, and it has a different category of outcomes, like the complete response, the partial response, the stable disease, or the progressive disease. Okay, then we also have the time to event data set, and it's based on the subject level ADSL and the adverse events, and also on the SDTM disposition and vital sign events. So this one is used for things like the overall survival or the progression-free survival, like the time without the disease progressing further, and the time to death, for example. And it has some key variables like censoring or analysis date or start date or something like that. Then we have the vital signs data set, which is based on the SDTM vital signs domain. And here we derive things like the body mass index, the mid-arterial pressure, or other similar vital signs. And this one is used when we're creating safety summaries. Okay, so there are many different variables in BDS. You can find them at my discovery. Yeah, not here. Not like this. Yeah. So I already showed this website in the last presentation, but I think it's quite useful. Because when you are a bit lost on what variable belongs to what data set, what that variable stands for, and what function from Admiral you are going to need to derive it, you can use this website. And here you have all the possible ADAM data sets and all the possible variable or parameter names and the description and everything. And you can even look for it if you want. You can look for one of them and just take a look at this. So now we're going to group the variables that we're going to be deriving next week. Oh, Tata, Fanny, were you going to Fanny? You were going to say something?
Yeah, yes. I was trying to go back presenting the ADPC or ADC. I was not sure the level of understanding of why we need to put certain domains under certain category, meaning, say, for example, ADPC, why do we need to put it as a BDS structure rather than CDS structure or ADSL structure? You know, the structure does matter, right? I mean, so
yeah, because you will have parameters, Fanny. So
yeah,
if you have parameters, then it will be automatically BDS. So occurrence dataset and ADSL don't have parameters.
No, I do understand.
Okay.
I mean, that's I mean, like you exactly nailed the point, you know, but the understanding of the regular user, you know, the user or the person who's starting, right? If he doesn't have the structural understanding of a PC, I mean, like pharmacokinetics. So if it doesn't have enough parameters, it could be as an OCD structure, or it would be directly listing. Then like, right. So that's when a brief introduction of the domain that we are trying to see and why we need to put it in that domain into this structure would give us a better understanding of entire BDS structure versus OCD structure, because they might be confusing for the starters. And say, for example, we cannot fit in the ADAE data set into BDS structure because of how the categorical complements, mild, moderate, median, right? So it cannot be fit into the eval and param CDs and others. So that's what I was feeling, like a brief introduction about the nature of the data set and why it fits into BDS structure rather than other structure would be helpful for the people to understand better. That's what I was feeling when I was trying to prepare myself with for ADPC.
Yeah, sure, please. No, yeah, I mean, I am from outside the pharma industry, so I don't have this so clear. You guys have it much clearer than me, so please correct me any time and do any clarifications that you need, because I just went through a lot of material very shortly this weekend, and I cannot understand everything in one weekend. So yeah.
No, BDS is such a long, and because most of 90% of my interview questions or the people who would like to hire me would actually ask me why you put this structure into this, why it is different from questionnaire data set is different from PC and all that. Individually, they would be, because those examples that been given into the IG guide would help us out. So actually, I'm not sure like how deep we can go into this one pharmacokinetics concentration. But when we were writing the book with Ben, I was part of that documentation process and all that stuff, that Slack group. And Ben had a very similar take on it, because too much of information into that documentation might make the user not able to understand, but the depth knowledge of the IG is really required. So that, like it's a catch-22 situation, like where we end or where we start close. It's up to because he was been referring to the IG for quite a long time, and it's just updated too. But those things, maybe we can refer back and saying that IG says this. That's the reason why we are trying to put this way.
Yeah, sure. I mean, even if you want, this is part of a GitHub repository. So if you want, and you want to add some information or some new slide here so that anyone in the future can see it, please go ahead and do so.
I would, I mean, like, if that's okay, like we can have a planning, and it's not just for us, right? People coming a long way would refer always to this and come back. I know, like, we cannot have too much information put on slides, definitely, but we can have those examples and, use it in a better way, and then use the Admiral functions to show that, okay, this is done because of this, the timing variables, and this is, so that's what I was thinking, but I was not sure how this group would be doing it, or this is my first time coming here. Okay. Oh, we'll do that.
Yeah, we're also struggling with finding an effective way to
because we are very little people, so not very little, but not too much people here, and I've been trying to do the presentations myself for these first weeks, but of course, coming from a different industry, it's been a bit hard.
So then my 2 cents are, right, okay, we do have the Admiral package, we do have IG. So my thinking, my 2 cents on it is, okay, let's concentrate the domain knowledge from the IG, because IG is a Bible for creating anything or everything, and then discuss through it why the timing variable is done certain way, how it is being collected at SDTM level, and why the SDTM level is look like that. So we have to go backwards, looking at the CRF. The CRF is the guiding document, right? The CRF has is the statisticians, they design in a certain way. Like say, for example, the baseline visit, the visit structure and everything matters for that.
Yeah, it gives you information how the database is built, where you can find in which information, because the SDTM, so the CRF gives you the information in which data sets you can find the information the SDTM will use, to put it just like that. Yeah.
Yeah, at that level, the SDTMs, how they are collected is basically the CRF is a guiding document. The CRF is actually like a roadmap. It's like a Google map for
Yes.
us. You need to know, I mean, like where you start and where you end and what are all is going in there. And like say that decides, the CRF is the one which decides. And for to design the CRF, the protocol is actually the bigger map picture. Protocol tells you what exactly is expected out of this trial. Is it what kind of a trial is that? What are the things that they want, and what is exactly they are looking for? What are the
Yeah, in this case, at which visits, you take a blood sample to check these the Tmax and so on, and the blood pressure. How often will you measure it? Those type of things.
yeah,
You'll
it comes
find in
from
a protocol.
it comes from the protocol. The protocol is the one. It defines. You need to have a definition, right? For each trial. Say, for example, you have a trial starting. There it defines what are the primary endpoints, what are the secondary endpoints, what kind of tables you want, what kind of listings you want. Everything is defined in the protocol in a very brief way, I would say. Not in a very, very brief way, how the missing data is handled, what kind of things that you want to look, what are the efficacy tables that you are looking for, what are the
That
safety
will
tables.
be the statistical analysis plan. So your protocol will describe how your study trial is set up. So what?
Sorry,
Yeah.
some sponsors do differentiate that.
Okay.
You're right.
Okay.
Yeah. Some
Awesome.
people have both, but as she was saying, protocol does define the primary, and then the second one is called SAP, which is statistical analysis plan, which defines the tables, listings, and graphs, or whatever it is, to achieve what protocol wants. Protocol says, I need this, I need this, I need this. And to get to understand or to explain how the data is, SAP defines that. And then all the tables, whatever tables it is, and those tables will decide which domains and what data sets you want. And like it is backwards compatible. Like if you take a movie out, the analysis data sets plans comes middle of the game, and like you go backwards. So that's what I was thinking of. Like we can deeply
Yeah,
go.
and also we have you now, but before we had a mixed group, so we thought maybe to keep it very technical. So what can we do with the functions and group the functions and more understand what is the meta core doing, what's meta tools doing, how do we create XPTs? Yeah. So from now on, yeah. So maybe we can let Julian give his presentation, and then in the end we can see how we can do it differently. With your expertise, we can bring more statistical programming into the picture, if it's okay.
I would love that.
Sorry, I not to hijack your
That's okay.
presentation, but I was thinking of, I was not sure like where to start and where to end on Monday, the last Monday. But thanks, Julian. Yeah. Please continue, and we'll talk later on. And
Sure.
But I was thinking better to have a better complete understanding rather than a technical documentation of it.
That would be great, because that way I can put my mind into why I'm using this function and not just how the function is used. So yeah.
Exactly. Sure.
But a quick question: how do we address you? Because now we call you Fani, but how would you like to be addressed?
Oh, he.
Key?
He. Yeah. He, she, him. That's fine.
No,
sorry.
I mean your name.
Oh, Fani Kumar is my name, and last name is Tata. Yeah.
Okay.
Tata is my last name though, but Fani is good enough.
Okay,
Perfect.
great.
Perfect.
I have just a question. I'm used to thinking of these things as databases, it would help me if I understood if these are one-to-many relationships, or what, for example, is it one record per subject or many records per subject? And are we measuring something to do with time? Is that what this particular database is all about? Or so in other words, a general understanding just what the object is about would be helpful.
Yeah, maybe there we can step in, Julian, if you like.
Oh yeah, no. In this case, as I told it here, this is the subject level analysis, but you are going to have more than one row per subject. So you're going to have one record, not only per subject, but per subject, per parameter you're measuring, and per time point. So it can, in many times, it's going to be measures over time. But correct me if I'm wrong, please, Sonaxi. Sometimes it's just going to be one subject, one time, but for one parameter, and then one subject for one time for another parameter differently. I'm not sure if this makes sense.
Yeah, so if you have measured blood pressure, it will be multiple visits, and if the time, if you have to measure it at one visit 5 times, you will have also time points. So then you will have visit, it will be blood pressure, then you will have a visit, and then you would have, okay, at 0, and after 10 minutes, and after 20 minutes. Well, the blood pressure is maybe not the best example.
I guess as you introduce each data set to just a comment like that, this one is time dependent measurements.
Right, I think that will happen in TTE, time to event analysis. Here we have time, but if you say you have meal consumption, currently I'm working in medical nutrition industry, and then you want to have the study product intake, and it takes 30 minutes, and then you will also have the duration. Something like that.
Yeah, Jim, can I, my 2 cents, I mean, basically the way that I want to explain is, if you're an database person, like say, do not think these are all rigid structures. First thing first, I mean, like if you're like coming from Oracle or Sybase and all that stuff, imagine that, break it down as simple as an Excel files in a structure wise. The one structure, the one would have a unique key, like an ADSL, one record per subject, and ADAE have multiple records for that subject. And most of the information that you want would be stored, the unique keys and all the unique keys would be in ADSL, ADTTE, and other structures, whereas ADAE would have remaining information related to adverse events, because adverse events happen more than once for one subject. It can start as a mild, it go for one time event, one time point, and next visit it could go back to mild to moderate, and then it becomes serious, or it can be otherwise around. So it will be having more than one record per subject per event. So when that happens, they come under the BDS structure or OCCDS structure.
Oh, yeah.
But when you can define that event, say for example, sex of the subject would be either male or female, and that remains same across whole study, right? So that would be unique record. The height, say for example, if it is not a pedestrian study, and if it is like a study which is happening for 35 and above, his height may not grow. So it will be one unique this thing. So that will be collected. So depending upon what domain you are looking, it would be either one record or multiple records. And that's where you break it down into different domains. Domains like the schema and all that stuff would be different for one this to other. And then when actually needed for the table or the report that you generate, you bring that information and this information together and generate the.
Yeah, actually, the BDS, ODS, and ADSL are different structures. So the where you're gonna merge is ADSL to BDS and ADSL to OCDDS. So it's a 101 because the subject ID will then be the key. So, but we're not really thinking in that way. So it's mostly then on SDTM level where you will have to see if it's a one-to-one or many-to-many. And for that, we have a RELREC dataset. So the RELREC dataset will describe how the domains are related. And then you will have the key. So the RELREC domain will have a one-to-one relationship for many. Say you want to know for which AE a certain medication was taken. So if you had diarrhea and you taken a medicine to stop the diarrhea, then it will be a one-to-one connection and it will be described in the RELREC. But then there is also one-to-many relationship. It's also described in the same RELREC. So both relationships are there, but that's more on SDTM level and on ADAM level. Yeah, just described. And for OCDDS, yes, you can have mild, moderate, and but it depends on your sponsor. If you will keep, say you have diarrhea, it's mild, and it goes to severe. It depends on your sponsor. So whoever is paying for the research, if they want to keep the worst symptom, yes or no. Yeah, in SDTM you will have both, but then in ADAM you will keep most likely the worst symptom, and that will be described in the statistical analysis plan. That's how you analyze the data. And then in OCDDS, the occurrence data set that's there for medical history, concomitant medication, and adverse events, you will not have things called analysis duration or analysis time point.
Right.
So those things you really have in a BDS data set where you work with ECGs, what is their blood pressure, pharmacokinetics, and time to event analysis is more there for purely to facilitate creating the Kaplan-Meier curve. Yeah.
Thank you.
Yeah.
Yeah, that helps.
I hope it helps. But we're not really thinking a lot about EDR diagrams, the SQL, how it's called, relational databases. No, we're not really thinking in that sense.
Yeah.
I think you guys know that there's a lot of letters in this business, a lot of acronyms, a lot of
Yes.
so that is not, to me, not as important as understanding, is this a measurement? Is this a time measurement? Or are we just collecting certain facts about the patient? Or it was, what kind of animal are we dealing with, rather than trying to memorize all the different things that you can try to capture.
Yeah.
That's all.
No, I totally agree. And SDTM for a beginner would be something which is nothing is going to be changed from the data. The raw data collected from the Oracle views, just move it to the SAS readable data format. And it is purely, the SDTMs are the raw form of the data.
Yes.
All raw form, how it is being collected.
Yes.
For the sake of analysis, for generation of tables, we convert the SDTM datasets to ADAM format. These are formats. Do not think that they are structures, but they are formats. Basically, how do you want to see, and how does the FDA want to see their ADAM structure, SDTM structure?
The ADAM structure seems to me to be like, we don't want it in months, we want it in visits, we want change the format for this date, calculate the difference between these two dates.
Yes, they want it's more of a standard structure.
Yeah,
very standard structure across all the industry. They want, see, they do not want to rewrite the code that used to be there. That used to be the case with the FDA maybe till 2010, I believe. Before that, or even 2000s, around 2000s, they used to write the code for individual sponsor because each sponsor used to have a different way of doing it. But
Yeah.
slowly they have standardized the structure they want to see. And that is exactly the Adam structure.
No. When you say structure, now I understand. I'm thinking about database structure. And that's what comes back to, wait a minute, they're all the same. It just depends on the key fields. What is the, got it. Now I,
Yeah, irrespective of how you collect, irrespective of how Oracle is collecting it, irrespective of how the sponsor wants to be, it can be a European style or American, I mean, the American way of style or Asian style of months or whatever, the different structure. But at the end, the structure has to be for the dates. Let's talk about the dates. It has to be ISO 8601 data format, meaning year comes first, month, and date. So the structure has to be uniform.
then a suggestion, just, I don't want to hold everybody up, but if we have well-defined goals like that, to
Yes.
maybe introduce, here's how we're going to do dates, here's how we're going to do difference between dates, but not get too caught up in all the different variable names, and because then I just lose it.
No, I totally agree. I mean, that was the initial part of my argument of this thing, like, because I was not sure of the audience, like, because the audience is very weird. I mean, a wide variety of it, and like, I was not sure like where to start.
Yeah, I believe that maybe the first, I mean, we haven't had the chance, but maybe the first introduction should have been made by some statistical programmer or someone who actually comes from the pharma industry, because otherwise, I was told I had enough background just by knowing R, but that's not the case at all. I come from the software industry and the fintech industry, and I really have had to read a lot. And I have just absorbed so much information that I'm probably getting many things wrong, and I don't have the correct structure in my head of how things work. I have tried my best with creating these kind of presentations, but maybe we can even rewrite them at some point if you want, and maybe even if you want, we can start over. I don't have
No. You're fine. You're fine. I'm just brainstorming out loud. It's almost like, well, I have a different approach, and because I don't know the clinical side, I'm used to, instead of giving things names, I would just like look at the data itself and say, what do you think we're doing here? Are we measuring something? Are we, more of an intuitive feel rather than throwing around all these 4-letter, 5-letter.
Yeah, then this presentation is all about these 4-letter and 5-letter things, because that's what I wanted to try to understand. Because I do come from a biological background when I did the bachelor's degree, and I wanted to know what all of these stand for before diving into the code. But yeah, maybe we can just go through the rest of the presentation.
Yeah.
And next week, if someone else wants to kind of prepare the workshop, or at least go through the example that we have, and maybe someone who knows a bit more about this can actually put some explanations between code and code, so that we can better understand what's going on behind, and not just this function does this and this function does that, which is what I did the last time.
My 2 cents on it is, say, for example, just knowing the functions might not really make you understand what it is doing it. Like, say, for example, date time variables, you have 4 different ways it throws out, like, say, date and time and why it is doing that. So just, backwards compatibility, or like why we do this, or what you do if there's a missing date or missing time, all those things.
That would help me out a lot. Yeah.
Would help the process of understanding rather than just knowing what functions we are using.
Mhm. Okay,
Yes.
perfect. Sorry?
Sorry, I didn't say that. I was getting about.
Okay.
Yeah, no, you go ahead with the
Okay,
presentation.
I'm going to go ahead. We're just
Bye.
going to finish this, and then even if later you want to stay a little bit or just comment something in through Slack, and we can rethink this a little bit.
Yeah,
Okay.
we'll do that. Yeah, we can brainstorm
Okay.
like what we can do. Yeah.
Perfect. Okay, then I'm going to go through all the variable names that Jim likes. So yeah, I'm going to go through several different variable types in BDS. I have divided them by different purpose, like timing variables, like parameter identification, like results, derived parameters, reference ranges, based on these all are the ones that are going to be derived in the example that we're going to be seeing next week. Based on unchanged, different flags that you can put, the treatment, the categories, some other flags that are criterion based, and some additional row creation or some imputations. Okay, so about timing variables, these variables just place when each observation happens in the study timeline. And what they help us do is to track when it occurred relative to treatment or relative to a visit or some other milestone. We have the analysis date, the analysis date time, the relative study day. Yeah, I'm not sure if I'm just going to go quickly over this and just not stop on each of them because okay, we have some other ones like ADTF, ADMF. These are imputation flags, and these track some incomplete dates. We also have the visit time and the visit, not the visit time, the visit name, and just a number to assign to this visit. And this we need this for sorting sometimes, or for when we are doing summaries. We also have when in what phase of the study we are, or in what period, just also for grouping. And then just for we have also treatment flags. Okay, we also have parameter identification variables. This define what is being measured. Like in invasive data structure, each record must correspond to a unique parameter per subject and per time point. So, for example, we will have a sort parameter code that explains what parameter we're measuring, the full name of the parameter. Optionally, we also can have an ID, a numeric ID, and we can also have these parameters divided by categories in some studies. We then also have result variables, and these variables, what they store is the main output of the analysis, like either a numeric result or what category of the result we're going through. Like A-val is a numeric result, A-val C is a character result, like maybe deceased or improved or whatever. And then we have this one, I actually don't remember what it did. It's just for categorization, like categorical variables.
Yeah, so you have categories and say it's about blood pressure, high, low, then you have avocat will be blood. No.
Okay.
No.
No.
If you have if you measure blood glucose and you can be pre-diabetic and diabetic, and then avocat will be pre-diabetic, diabetic, and the numbers that being measured will be in AVAL.
Okay.
Yep.
Okay.
And AVAL's the C, the character is just the character form of AVAL. Or A value analysis value.
Perfect.
Values is analysis. A value stands for analysis values. So like as she was saying, original units, right? Could be in anything. Could be in grams, millimeters, millidecimal liters, depending upon all those things, right? And those character values could be negative, positive. Results could be anything, right? Sometimes the values of X-ray could be, or if you see a blood report, you will all see sometimes it was is positive. The value is a positive. The word positive means something in the report, and you are tested negative for it, right? So those characters, and those cannot be replicated in numerical values, either it is positive or negative, right? So those kind of original units, when original units have been collected at SATM level, those things, and if you need to have either if heights is measured in centimeters or meters, depending upon which country or or where the trial is done, you convert them back into the standard units. You do all those things and put those numerical values, if there's numerical values inside the eval and eval and eval C, and those units, sometimes if the BDS structure we do not have units for them, we do not have a column for units. So eval would have brackets in there, and those could that would go into the param field. The results and the actual test done and all those things, and the values would be in that. I think somebody was asking where the units will go, right? That's what I was trying to. Yeah, units are stored under the param field, and that's but actual value will be stored under eval.
Okay.
We understand the difference, right? The difference why analysis value. A stands for analysis and value, which is a standardized unit, a standardized value. And this is the value that we are going to take to generate the summary statistics.
Okay, perfect. Yeah, I think I more or less understand.
Yeah, and the summary statistics, mean, median, mode, and all that stuff uses eval. And frequency statistics, the frequency, everything goes to the eval C. And most of the time, if it is a numerical value, some people try to have everything in eval, and eval C is exactly the same, meaning that there is a character way and there's a numerical one. But eval C, which is having negative or positive, which cannot be converted, eval could be missing. Those are the other things that you need to keep in mind, that eval could be missing, but eval C might be copied in a character.
So at least one of them has to be present.
No, not at least, but most of the time they both will be there. So
Otherwise, they both are going to be there.
Yeah. According to IG, indeed, or either aval or aval C needs to be there.
Okay. Yeah, either eval or say if that's okay. But Pinnacle would say throw up an error or warning saying that one of them is missing or anything. But both should be required variables. That's another thing that you have to keep in mind, right? If both are required, right? If the eval and eval C are
required. Okay.
Yeah, we need to check that. We need to check whether it is a required variable or permissible variable. We'll get back to it, because there are certain things that we need to keep in mind, that some variables are required. Some requires are permissible, meaning that they can, if they are all missing, we can drop it out. Something like that. Yeah. That's
okay. Perfect. Then we also have some derived parameters that these are used to compute some secondary or some composite measurements that are derived from other primary variables. Like, for example, we can create if we have the height and the weight, we can create the BMI variable. And these are just derived from other more standardized variables. We also have then the reference ranges, and these are helpful because they help us classify whether the values are within normal clinic limits or not, or if they are too high or too low or something like that. And so we have okay, I don't remember this this slide right now. So yeah, we have
no, these are lab values. So if you have with lab values, you have a reference range. So and the lower range is stored in analysis reference lower and analysis reference higher. That's the higher end of the range. Yeah, now you can skip this.
Okay, so this is the low
Yeah,
and the
yeah.
high limits for a parameter. For example,
Yeah, and then you will have analysis windowing variables if it's out of the window or not, and how many shades different. Yeah.
Okay, yeah, and now I remember.
No worries.
Yeah. Okay, perfect. And then we have also baseline and change variables, and they allow us to compare on treatment variables to some defined pretreatment baseline. So we have like the baseline value that we are going to compare with. We have also how much has something changed from that baseline, what percentage has it changed, and then some flag for the baseline, and just what type of measurement is the baseline taken on. We also have some flags and for filtering. That these are like binary flags to identify records that are
1 second.
relevant
For the sake of Jim, I mean, like if you go back, Jim, this baseline is something, you need to understand what a baseline is first. So for example, we are having something collected over 10 visits. 10 visits, say visit 1 to visit 10. And the patient comes in on the first day for the visit. And that visit should happen for all 10 weeks, meaning every week he's going to come back. So what happens is that his baseline, I mean, his information, all his information is collected at either on screening. It depends upon the sponsor's way of defining the baseline. Either it could be screening or visit 1. So you understand, right? So on visit 1, he comes in, he has certain levels, say, for example, his blood pressure or his diabetic, whatever you can collect whatever the trial is for. You collect that, and the subsequent visit where the actual dose, either it could be placebo or whatever drug it is, it's been given to him, and he comes back and they try to analyze the whatever the goal, or it could be a headache or anything, right? Remaining visits, all the 10 visits. So what happens is that they try to compare with the value, the baseline value. If it is greater or less than the change is the variable that is going to be, is it more than the baseline value or less than the baseline value? And the percentage change is also been calculated using the base and the change values. So P change and absolute baseline, like there are 3 different ways, all calculated using that baseline definition. So you need to understand the definition of baseline as defined in the protocol. So it is defined there, and it changes from each study to other study. I mean, like it's not standard. You have to understand how it is defined and then do the calculations in an analysis data set. And it is not done in the SDTM, the change and P change. You don't find that at SDTM level, but you need to do it at Atom level. Am I clear? I mean, I'm just trying to see that, Jim is trying, I mean, like coming here, right? So I'm just trying to explain that. Yeah. I mean, like these things could be confusing why there are so many of them, like you can do it, but these are all derived. A baseline is sometimes you have to define, and remaining things are comes from the baseline.
Yeah, it's mostly used for statistical analyses.
Yes.
And for figures to show the change in the formula baseline.
Yeah, these are all used in the tables. Basically, the reports that you're going to use or generate, these are all helpful. To say, for example, there are a lot of tables called mean deviation plots or mean deviation tables. You use the change or percentage change, depending upon what kind of tables you're doing. So you do not want to do like entire analysis for 10 visits. Just say what is a change? What does a change will tell you? Change will tell you a lot of history or what the data is speaking out. Okay.
Okay, perfect.
Sorry, Julian, I just want to break it, but I just wanted to have more explanation on this guy. this thing.
Yeah, no problem. Anytime you want, please interrupt me and ask some clarifications, because you know much more than I do about this. So
I'll try. I don't know much, but yes, I'll sure.
okay. Yeah, then we have several binary flags just to identify records like that are relevant to different analysis or the table and listings. Like for example, something to say that like a sequence number, for example, and a flag that is like represents the primary analysis record. I'm not going to go too much into detail in that. We then have the treatment assignment variables that what they tell you is what was the planned treatment for this patient, and then what the actual treatment received was. Then we also have some other categorization on other criteria, like we apply like different we can create different groups based on the results of these like variables. Like for example, if you had like a threshold in one of the parameters you're measuring, like if you are above that threshold, you are from one category, and if you are below that threshold, you are in another category, for example. Okay, then most of the time, if not all the time, usually the BDS datasets, what we need many times the subject level attributes that come from the ADSL that we saw in the previous session. And what we usually do is we just merge this table into the ADSL into these tables, so that we can have now different things like the age, the sex, the treatment start date, and several other variables. And this allows us to create some new records, like creating summary rows or getting the worst value for that specific age group or for that or whatever.
Could you go back to that?
Yes.
Derive
This
new
one?
records. Do you mean new rows, right?
Yes, each record is a row. In basic data structures in BDS, each row is like a one-time recording for one person.
For one, right. So okay, so a summary or an average are different columns from worst. You'd have, these would all be different columns for that one person.
No, I don't think so. I think these are new rows. Like if you want to
New
create,
rows.
yeah, if you want to create like to get, for example, what the worst value is for one, like if you are creating, like imagine you're creating a different table, like you have this table with the blood pressure, for example, and you want to get the highest blood pressure. Then in R you would use the summarize, for example, function. So this is much more or less the same.
Yeah, summary rows would be maybe the total bottles you consumed or something. Worst value would be another parameter, and the average blood pressure
Right.
over 3 days.
Are you carrying subject level variables in each row then? Age, sex, treatment?
No.
Yes, you will repeat it.
You're repeating it.
Yeah.
Okay.
It's redundant. Yeah, in Oracle or in a relational database, it would be redundant information.
Yes,
but yeah,
yes,
we're
yes.
repeating it.
Okay, okay, thanks. Thank you.
But in a listing, we don't. In the listing, we show it only once.
Yeah, Jim, the way it is sometimes, say for example, unique key, which is subject ID, would be repeated across all of them, irrespective of whether it is. And when you merge the unique keys, like say a 1 row per record, yes, it will be recorded. There will be coming situations where you wanted to have, as was they were mentioning about a total or an average or some kind of 10th percentile, for that subject record, right? So you cannot have a column for 10th percentile because you would take, say, for example, average of first 5 visits. It's not entire. So you need to have the dose that has been dose calculated, dose average out for first 10 visits or something like that. And you're trying to make a summary for average dose per 10 visits. So what happens is that the easiest way is to calculate the 10 rows and put it back as a new row, attach it as a new row. And when you do that, to have most of the Adam is about the traceability, right? Tracing, you have to go back to the roots. Adam structure is mostly for traceability. So what happens is that when you do certainly that way, you would have another row, another column called D type. What is actual type? You're doing it for that record. So that record where you'll have a new record will tell you whether it is an average or it is LOCF or MOCF, how exactly you derived that record. That record would have that type variable populated. D type is getting populated. And there will be, the param would be saying that it is called derived. That record is derived. It is not directly copied from the SDTM.
Oh, that's good. I didn't know that myself.
Yeah,
so that's great.
That is where you see the difference between the actual records, which are directly coming from the SDTM, and the derived records.
Okay, so it's always one single table, and it's not like a separate summary table from the table. You add a row, and you have like this flag with this column that is a flag that it tells you if it's a derived row or if it's an actual row for the subject.
Yeah, and when you're actually calculating the table, you actually use that variable D type is average or LOCF or whatever it is, subset it, and you have one record, or you don't have to have everything. The end of the point is that you do not want to do much processing at the table level. You want to do everything at Adam level. That is a philosophy here. The philosophy is one proc away, meaning that the reports that have been generated have to use proc report, just the proc report, nothing else. So all the calculations you want to do it is at an Adam level, so that the FDA, who is a reviewer, can check whatever the derived variables at their end, because they are going to recheck everything for us. So whatever you're trying to do, derive everything, it has to have a traceability and clearly done. So these are the two main things. So you understand right now why we need to do a new record. New record is for the sake of traceability and easy table.
Okay, perfect. Thank you for that. Yeah. Okay, then yes, after the merge, yeah, we will go into the hands-on workshop that we're not going to see it today. Just so you can see it. It's an example as well that is slightly different from the pharma examples that we've been looking at, but it's quite similar. In this case, we're going to use just the Admiral library, and we're going to be deriving all these types of variables that we have been describing right now. So we are going to see how everything is derived and which functions that we're going to need from Admiral to create this data set. And yeah, just a quick note that we're going to see just one BDS, like the vital signs one, but the others are the workflow is very similar. We're going to be deriving from different SDTM domains or from ADSL using Admiral functions. So I believe it's a bit redundant to go over all the examples from the pharmaverse examples, because I was taking a look at some of them, and most of the time, many times you are deriving again and again, for example, the numeric date or the time variables, and it would get a little bit tedious. So I think that with just one very large example of deriving all these many different kinds of variables, we're going to have enough. But yeah, maybe we can later discuss if we need to do another sort of more generic introduction to civics or whatever. And that would be it. Okay, so yeah, thanks a lot all for coming. I'm going to just stop the recording right now, and if you want, we can discuss a little bit about this.